So let's look at a couple more example problems where we'll need to use the Pythagorean theorem in 3 dimensions. And these two example problems we'll look at are going to be a little bit easier than the one we looked at in the introduction video where we had a rectangular prism. But these can still be a little bit challenging. So for this problem, we have a square pyramid shown below, and it has a base with sides of 10 units. So it's a square, so all of these are 10. And the slant height of the pyramid is 8 units. So the slant height is going from the corner to the midpoint here of this line, and we need to figure out the height of this. So basically, the square pyramid has symmetry so that this drops down straight below. And if we wanted, we can even draw another line out there. But the main idea is that if we were to draw a line to the other side, and it's not perfect, so let me make it a little bit better with the line tool. But if we drew a line to the other side of the pyramid, then essentially this entire line across is going to be length 10. So that means that each of these would be length 5. Because again, this vertical line here is going to split it right in half. So we now have this right triangle, and let me redraw this, but because we have a right triangle, we can use our Pythagorean theorem. Since remember, with the Pythagorean theorem, if the side lengths are a, b, and c, and it's a right triangle, that a squared plus b squared is equal to c squared. So let's look at our specific triangle. We have a height, which we're going to call h, and we know its bottom leg. We can call that length 5, since we were able to find that. And its hypotenuse, the long side of the triangle, is 8. And of course, we know this is a right angle. So using the Pythagorean theorem, we can say that this is A, this is B, and this is C, so that we have that h squared plus 5 squared. These are the two legs, and we're squaring it. And this is equal to the hypotenuse squared. So now just simplifying everything, 5 squared is 25, 8 squared is 64, and we're going to subtract 25 on each side. So that h squared would be, well, if we take away 5, we're at 59, take away 20 more, we're at 39. And now we just take a square root of each side. So that h is the square root of 39. And we're not interested in simplifying this since we need to round our answer to the nearest tenth. So we really just want to plug this into our calculator. And this is not a perfect square, so we're not going to get a whole number answer, but we can still get an approximation. So when you plug this in, h is approximately 6.244997 and so on, but we're rounding to the tenths place. So 6.24, we're going to round that down. So 6.2, and we just have units. This will be our final answer for this one. This is the vertical height of this square pyramid. So let's look at another example now, where again we'll need to use this Pythagorean theorem for a 3-dimensional shape. And in this one, each vertical cross-section of the triangular prism shown below is an isosceles triangle. So remember with an isosceles triangle that they have 2 equal side lengths, so this would also be s, this length here, and the angles opposite those equal sides are equal as well. So when you have an isosceles triangle and you drop a vertical line that's at a right angle, you end up splitting it in half. So this triangle here and this triangle here, these are the same triangle. They are congruent. So what that means is that this length here and this length here, these are going to be equal. And so if the total length is 4, that means that each of these are length 2. So we can focus on one of these right triangles. Let's just pick the one on the right and redraw it, and then use the Pythagorean theorem to find this missing slant height, which we call s. So this is 5, this is 2, this is a right angle, and this is s. And since we know the Pythagorean theorem, a squared plus b squared is equal to c squared, we can just match up the letters and plug them into the equation. So the c value, that's our hypotenuse, that is across from the right angle. So that's our slant height s, and a and b, it doesn't matter which we call which. So let's call 5a and 2b. We get a squared, which is 5 squared, plus b squared, which is 2 squared, and this is equal to c squared. But c, that's our slant height s, so you get s squared. Now simplifying, 5 squared, that's just 25. 2 times 2 is 4, and adding these together, we get 29. Now to cancel out that square, we take a square root of each side, and so s is the square root of 29. But we want to round this to the nearest tenth. So we know it's not a perfect square, so it's not going to be a whole number, so we need to use our calculator for this. And the square root of 29 is 5.385 and so on, but we're going to approximate this. So we need to round it to the tenths place, so 5.38, we're going to round up to 5.4. And this doesn't have any particular units, so we can just say 5.4 units. So that will be approximately what this slant height is in this triangular prism.